Okay, so good day, everybody. My name is Chidera, and I am part of the TCN2501 cohort, which is for Think Cyber. And today I'll be presenting on real-life applications of Python in cybersecurity. We will explore how Python helps automate tasks, detect threats, and analyze security incidents. So let's begin. Why Python for cybersecurity? Cybersecurity professionals must work quickly to identify and respond to threats. And Python is widely used because it allows us to do things like automate security tasks, reducing manual workload, detect and respond to threats by scanning logs and network activity, analyze large amounts of security data for better decision making. So Python's efficiency makes it an essential tool for cybersecurity analysts. Now let's explore its application in real world scenarios. The first thing we're going to talk about, the first thing that we did in labs was variables and data types. So Python variables and data types help store and manage critical security data. And in cybersecurity, we often deal with structured and unstructured data, such as user credentials, log files, and network addresses. So to efficiently store and manipulate this data, we use different variable types. Now, we're going to talk about variable assignments here. So this is basically the process of giving a name to a value. For example, we can store an IP address in a variable so that it can be checked later. And data types, um, Python offers different types of data storage, such as integers, strings, lists, and dictionaries, which are useful when handling security logs and user data. In the example that I give here, content equal to this string right here. And in order to get the data type, we input print type and then get the name of the variable, which is content. And in this scenario, the data type is string. So now we're moving to the use case. So the use case for this um lab is detecting unauthorized USB devices. So many companies restrict USB access to prevent data theft. Now, a Python script can compare newly connected USB devices with a list of approved devices. Now, if an unapproved device is detected, then an alert is triggered, preventing unauthorized data transfer. So, in order to do this, we are creating a scenario where there is a list of devices that are allowed, and then and then there is a variable called um, connected device, which is the device that is connected. So in this scenario, this is the list of devices that are allowed, and this is the device that is connected. So if connected device not allowed, if connected device not in allowed devices, allowed devices is obviously the name of the list of devices that are allowed. Now, connected device is the name of the device that is connected, like so. So we're using the if condition to print unauthorized USB device detected if the connected device is not in the list of devices that are allowed. Unless if it is in the list of devices that are allowed, then it will print USB devices authorized. So basically it helps us mitigate data theft and just protect data in our computer. Next thing we're going to talk about is basic functions. So functions are essential in Python as they allow us to automate security tasks efficiently. Now, instead of writing the same code multiple times, we can define the function once and call it whenever needed. So the reason for this is because the code is reusable and it helps in incident response. The use case that we're going to talk about, okay, we're going to talk about a few built-in functions like print, len, sum, and these are basically some of the functions that we use. And then in order to create a function, we use the def function. Again, def is for define, so we define the function and then include the parameters that we want. Now, the use case that we're going to refer to in this scenario is um detecting suspicion file downloads. Now, attackers often disguise malware as legitimate files. A Python function can scan system logs for file downloads from unapproved sources and alerting security teams before any damage occurs. So by using functions, we can make our scripts modular, easier to maintain, and more efficient. The syntax we use here is firstly import the OS, which is the module that we're referring to. And then this is obviously a list of downloaded logs. And then in this function that we're calling out, that we're creating, we define detect suspicious downloads. Obviously, we're trying to detect suspicious downloads. So for log in logs, if unknown sites.com in logs, then we print alert suspicious file download detected. And now we're going to use the function that we had just created to call out download logs. And once we do that, we realize that this is an unknown site, so it will print out suspicious file detected. Now, moving on to the next slide, talking about slicing and casting. Now, in cybersecurity, we often need to analyze raw logs to extract specific pieces of information. Now, Python slicing and casting capabilities allow us to retrieve and process relevant data efficiently. So slicing, this is a technique that lets us extract a portion of a string, such as an IP address or a file name from system logs. While casting is just allows us to convert data from one type to another, such as changing a string representation of a number into an integer. Now, the use case that we're going to refer to, or firstly, let's talk about this example here. We say name equal to Chidera and print name, and then we slice it. So there is start, stop, and step. Start in this scenario is 3. So it will look for the third index, and the variable that we're referring to obviously is name. And the third index is 1, 0, 1, 2, 3. It starts from 0. So this is 0, 1, 2, 3. And then it will print to the end. Obviously, there's supposed to be a stop after this colon. But like since there is no stop, it will just go to the end. So if I wanted to stop, I could say 3 colon 5 or colon 6. And then step it will just keep skip a bunch. So if you said step 2 or step 1, it skip 2. If you say step 1, it skip 1, and it just keep moving like that. So the use case that we're going to refer to is basically extracting suspicious file names from logs. So if an attacker downloads malware onto a system, security analysts must identify the exact file name. So using Python can help search logs for entries containing download and extract the file name associated with them. So this helps security teams quickly investigate and mitigate threats. So in this scenario that we're creating, keep in mind this is just a scenario. So say there was a file. I mean, we created a variable named log entry, and this is what was inside. User downloaded.malware.exe. Now file name equal to log entry. We're trying to like split the um variable that we created that has been created or for the downloads that we have. Now if we split it, we're trying to get the suspicious file or the file name. We're trying to get the file name to be exact, and we are splitting it to find the exact place the file name would be. So if we split and then do this, we can print suspicious file detected if the file name is malware, because it's malware they're trying to detect. So it say suspicious file detected and then say malware. So this obviously would be useful in cybersecurity because it helps security teams quickly investigate and mitigate threats. The next thing we're going to talk about is loops. So loops help automate repetitive security tasks such as scanning networks, processing logs, and monitoring system activity. So in cybersecurity, automation saves time and improves efficiency. So we talk about for loops, talk about while loops. For for loops, they basically allow us to iterate over lists or logs, checking multiple entries for security threats. And the while loops, they allow continuous monitoring of events until a security condition is met. In this scenario, name equal to these characters and obviously the string. So for I in name, using the for loop, we're trying to iterate and loop through all the characters in this string. We say print I, and this will loop through everything and it will print all the characters one by one, including the spaces. Now, the use case. So monitoring USB device connections. So attackers may repeatedly connect unauthorized USB devices to bypass security policies. So a Python loop can continuously monitor USB connection logs and raise an alert when unknown device is detected. Right. So by automating this process, security teams can ensure that unauthorized devices do not go unnoticed. So this is the syntax for it. There is a keep in mind again, this is just a scenario. So imagine there is a um list of devices that are connected. And obviously device USB 1, 2, 3, 4, USB. These are just examples of devices that will be connected. And then there will be also a list of of authorized devices. So if we use a for loop, we can loop two devices that are connected like this, and we'll check if the device is authorized. So if it's not authorized, it will say unauthorized USB detected, else say it's authorized. And obviously, this will help in protecting our information, protecting our data, and also helps make our work easier. So it helps in automation, and that's why loops are important in basically Python and cybersecurity as a whole. The next thing we're going to talk about is input and output. So securely handling input and output operation is critical in cybersecurity. Python allows us to read and write data safely, so it ensures sensitive information is not exposed. So read logs, we write logs, and this is important in cybersecurity. The use case we're going to refer to is logging unauthorized firewall access attempts. So when an unauthorized IP tries to access a firewall protected system, Python can log the events in a file for later investigation. This enables analysts to track repeated attempts and adjust firewall rules accordingly. So if we already have an unauthorized IP and we put it to obviously the IP here, um, we'd use with open, this is the name of the file, and then we append it. So what we're trying to do is write file and unauthorized access. This is the information, and then we call out unauthorized IP. So it prints alert unauthorized firewall access log. So if this IP address in this scenario, we already know an IP address that it's not supposed to be in to no, that's not supposed to have access to our device. So if we use this, we're trying to see that, oh, has this guy tried to access our device, and if um he does, then we'll get an alert saying unauthorized firewall access logged. Next thing we're going to talk about is modules. So Python modules expand its capabilities, making it a powerful tool for cybersecurity. So we have built-in modules and third-party modules. So Python includes modules like OS for systems and commands for system commands and sys for system level interactions. So third-party modules, libraries such as PSUtil help monitor network activity. Now we're going to talk about the use case and the syntax. So the use case in this scenario is detecting suspicious network traffic. So by using the PSU2 model, cybersecurity teams can monitor unusual spikes in network traffic, which may indicate a data breach or attack in progress. Python modules allow us to build advanced security tools with minimal effort. In the syntax, we import PSU2, and as you can see, PSU2 is imported. So net usage equals PSU2 dot net IO counters, and then we use the if condition to detect unusual network traffic. So if this is greater than 1 million or this is greater than 1 million, then we print unusual attacks. So obviously, as a result, you would see unusual network traffic detected. So what we're trying to do is basically just check if the network traffic is unusual, and it will help us identify whether something is going on, and it just keep us alert as cybersecurity engineers. The next thing we're going to talk about is custom functions. So creating custom functions allows us to build tailored security solutions. So it helps us in incident response because functions can automate the collection of logs and generate security reports. And also helps us in manual analysis because a function can scan files for known malware signatures. So in the use case that we're referring to, we are trying to see if we can automate malware log analysis, right? So security teams must quickly analyze large volume of malware logs to detect threats, and Python functions help automate this process. filtering our filtering out critical details for further analysis helps us reduce response time and enhance efficiency. In this scenario, we're trying to create a function that does that. So we define analyze manual log, and then we create the parameter. So with open, this is the file, and then we read the file. Log, we want to file the read lines, which will go through the lines one by one. And then malware equals to for log and log. This is a loop. So if malware and log, then we return malware. So this is basically how you create a function, and this is the use case that we're using for it. Next thing we're going to refer to is vulnerability scan. All right, so a key part of cybersecurity is vulnerability management. Python can automate this process, helping security professionals identify weaknesses before attackers do. Now we're going to talk about port scanning. So a Python script can check open ports and a system, sorry, and alert security teams if a service is exposed. Now it also helps in OS detection. So Python can identify operating systems to assess security risks. Now, the syntax we're using is firstly we import OS, and then we define the function we're trying to create. So we're trying to scan it network for vulnerabilities, and that's what we're naming it. So we input the IP address here. So we print scanning, right? And then we input the IP address for vulnerability, and then we say OS the systems. We use nmap to do this. So once we call out the function and then we input the IP address we want, we get the information that we're needing, so that we can check for vulnerabilities, and the information will just be lined up there, coming on one by one, right? And that's why it's essential to know how to use Python, because it helps in vulnerability scanning. Now the lessons learned, so and the challenges faced. Challenges we faced were debugging errors, handling large data sets, and script optimization. The lessons that we learned is that automation improves efficiency. So automating routine cybersecurity tasks like log analysis and vulnerability scanning saves the time and reduces human error. Python is also a powerful tool for cybersecurity, because Python's versatility allows us to seamlessly integrate into various cybersecurity domains, from network analysis to system management. Now, cybersecurity industry application. So we can be an SOC analyst, penetration tester, incident responder. As an SOC analyst, we use Python for automating log analysis, monitoring network traffic, and detecting potential threats. An example of this is basically automating the passing of large log files to identify unusual behavior and flag suspicious IP addresses. And we can also be a penetration tester. So we just leverage Python for reconnaissance, vulnerability scanning, and exploit automation. An example of this is using Python to automate nmap scans, I did before, for port scanning and service detection and target networks. We can also be an incident responder, which basically automates the collection of logs, evidence, and malware analysis to respond quickly to incidents. So an example of this is automating the extraction of system logs after a security breach for quick investigation. In conclusion, and future planning part, I'm going to talk about the summary of the Python skills that I've learned. So automated cybersecurity tasks such as log analysis and vulnerability scanning. Also gain experience in Python modules, custom functions, loops, and input outputs. Also handling for security applications. Now, plans to explore advanced topics. So machine learning and AI cybersecurity is one of them. And exploring how machine learning can predict and identify threats in real time. Also advanced Python libraries, diving deeper into libraries like Scapy for network analysis and requests for IP-based security tasks. Now appreciation. So special thanks to Think Cyber Nigeria, XC105 trainers for providing the knowledge and tools to build real-world cybersecurity solutions. Thank you.